Hey friends, welcome back to the channel, and in this video let's discuss about the database replication when we are designing a system. And mostly database replication is used in many database management systems, usually with a master and slave relationship. So first let's discuss what is the master and slave relationship. So basically we have a main database which we call as master, and it has certain copies which we call as slave databases, and all the data modifying requests from the web servers like insert, delete, or update, all of these requests goes to our master database, and all the read request goes to our slave database. And whenever we have any update in our master database, we have this replicated into our slave copies as well. Now, in most of the systems, generally speaking, the ratio of reading and writing, or the number of read requests, is generally higher than the write request. Hence we have more number of slaves databases in our case. Updated system is going to look something like this. User comes on a mobile app or a browser, access uh, some website and have a IP address returned from DNS. It then requests HTML page from our servers. And about this servers, we had discussed in the last video how the load balancer works and how we scale the web tier. And now we have this database tier in which all the write requests are sent to the master database and all the read requests are sent to the slave database. And we have a and we have a sync between the master database and slave database, so that we don't have any inconsistencies between the databases. So now, as we have discussed what is the database replication and how do we scale that, there are certain advantages to this. So first is better performance. In the master slave database replication method, we have master database for all the data modifying request and slave database for the read request. So we can have multiple requests in parallel, which does improve our performance. Second is reliability. So if one of your database is destroyed by some natural disaster or something, the data is going to be preserved because we are going to have multiple copies. So let's say this master database gets destroyed, we still have our database in our slave databases which we can use. So third is high availability, and this is because we have multiple replication of our database across masters and slaves. So if any one of them goes offline, our application is still going to be up, or website is still going to be up, because we have other databases to take care of that, or take care of the other requests. Now, in the case of database goes offline, there are two things. First is either the master database goes offline or the slave database goes offline. Now, if the slave database goes offline, then what we'll do in this case is we are going to redirect all these read requests to our master database. So for short period of time, master database is going to handle all the requests, be it data modifying or read request, and in the meantime we'll replace the slave database with the new one, so that it can handle the read request. And the other case would be that the master database goes offline. Now, in this case, if we have multiple copies of slave databases, we are going to promote one of them to a master which could handle these write requests, but it is not that easy. And there are some complex systems about how we can promote the slave database. Now, the other thing what we can do is to have a data replication method, which is a multi-master. Now, in this case, what happen is we have multiple master databases which will handle the write requests. And why do we need this kind of replication system? So first is, of course, sharing the load. So if one of the master database is handling too much requests, it can be overloaded. So to share the load, we have multiple master databases so that it could handle some of the requests, and the other requests would be redirected to other master database. But The second main thing is to mitigate the SPOF, which is single point of failure, and maintaining copies. So, like we discussed here, how our system is going to be affected when the database goes offline. And in this case, if one of the master database goes offline, we'll redirect all the write request to our second master database. Also, we can use it in another way as well. So if we are maintaining copies of master database, so let's say we have different kinds of services, and we want to update our database to our newer version. This generally happens at least once a year when we are upgrading our application. So in this case, what we'll generally do is will use one of the master databases to test our services on the newer versions, and we'll have the other database for the general read write requests. And third is to have lower latencies across geographies. So consider this: we have one master database, and we are requesting some kind of update or some kind of data to be modified, and we are situated in some other country. So for example, this is in US, and we are in India, and we are sending some kind of request. So obviously there is going to be delay because of the distance. Now what we can do is to have this in the US and other master database in India. So in this case, we'll have low latencies because our all of our data modifying requests are going to be going to this master database too, which is located nearby, and hence our requests are going to be faster. Now, what are the cons? So first is the eventual consistency. So this is basically when we have multiple master databases, and let's say I'm in India and I am sending some kind of update or delete request to our master database 2, and it has to in the future synchronize this data to this master database 1. It is not going to happen at that particular time, but at one point it will. And this is basically the eventual consistency, which is the system is going to be consistent, but not at that particular point, but in some future. Second is the result of this, which is conflict resolution. So for example, the conflict resolution will have, let's say we have updated our favorite food to burger, but in the master database 1 it is still as pizza. Now when we are replicating this data across the multiple master databases, we have the conflict, which is the favorite food that has been updated. So in this case, we'll have to resolve the conflict, and we have different techniques how to resolve this conflict that we'll be discussing in the upcoming videos. And third is the sluggish performance. So this is basically this happens when we are replicating our data in the multiple nodes. So in this case, we have uh, two master databases, but when we are talking about at scale things, this is going to be nasty a little bit, because we'll be using significant network bandwidth when we are talking about consistency among the master databases. So this could lead to sluggish performance as well. Now there's another concept, which is the cache. Now consider this example the in which the web servers are querying databases regularly, and this could lead to a performance problem. So in this case, to enhance the performance of our system, we have something called as cache. So what it does is, whenever web server sends a request, it checks in the cache if it exists or not, and if it does, it simply returns data to our web servers. And if the cache does not have that request or the data, it will query our database, and database will return that data to the cache. And if it is in our policy to save it, the cache will save it, and then it will return data to our web servers. Now, looking at the whole system diagram, it will be looking something like this. The only thing added here is the cache. So whenever we have a web server sending some kind of request, it is first going to query it with the cache. And it does get the data that is required, it will simply return the HTML page or anything to the user. If not, it is going to go to our database tier and query our database. Now, there are certain considerations that you need to look at. So first is the single point of failure. Of course, if we are using a single cache only, if it goes offline, we have a single point of failure and will be going back to querying our databases. So for that also, we can have multiple cache, and we need to synchronize data among that. Now, second point to consider is when to use cache. So cache is generally a volatile memory. So if it restarts, then all of the data is gone in the cache. So this is not suitable for the persistent data. And other thing to note here is cache is generally used for the data that is frequently read and infrequently modified. So these are the most of the use cases and things to keep in mind when are you using cache. Now, third is the consistency. So this involves keeping the data store and cache in sync, because the data modifying requests and the read requests from the cache are not in single transaction. And when we are scaling it to multiple regions, and maintaining consistency between cache and the database store is quite challenging. So you should keep in mind how these things work and what you should do when we are talking about keeping the data consistent. So fourth is the expiration policy. So it's generally good to have expiration policy in place in our cache, because if we don't have an expiration policy, the redundant data can be in the cache for too long and basically permanent. And this is basically going to nullify why we have put cache in place. And if the cache has redundant data, then the performance is going to be impacted. And the other thing, when we are talking about having an expiration policy, is to have a sweet spot between not short term and the long term as well. Because if we have a short term expiration policy, it will cause the system to reload data for the database very frequently. And if we have expiration policy too long, then the data can become redundant or stale in the cache. And fifth is the eviction policy. So this is when the cache is becoming full, or any new request to add items in the cache that can cause existing items to be removed. So this is called the cache eviction, and we have multiple algos or multiple concepts, and the most popular of them are the least recently used, or the least frequently used, or first in first out. So these are the kind of eviction policies that you can use for your cache. So this was the whole discussion about the database replication and why do we need to replicate our data, and how we can boost the performance by having a cache in place. And in the next video, we'll be talking about CDN, which is also going to boost the performance of a system to load the static data across geographies. And about its working, we'll be discussing in our next video. So that's it for today. See you in the next one.